Dear students, welcome to another session of physics lecture. Today, we are going to discuss a topic from the chapter Work Energy Power from 11th grade. This topic is easy, but it's very important in all competitive exams. You can see a question related to it. The topic is relation between kinetic energy and momentum, linear momentum and kinetic energy. Okay, so look at this. All of you know that. What is the expression for kinetic energy of a body? A kinetic energy of a body of mass m moving with a velocity v. You know that k is equal to what? Half mv square. All of you know this formula. It's a very familiar equation, right? K is equal to half mv square. And what is the equation for linear momentum? Linear momentum is a product of mass and velocity. It is denoted by the letter p, right? So p is equal to what? M into v. Kinetic energy is half mv square. Linear momentum is mv. Now, how can you relate these two? What is the relation between kinetic energy and momentum? That you can easily find. For that, I'll be taking kinetic energy equation. K is equal to what? Half mv square. This is the kinetic energy equation. Now, if you are multiplying and dividing it by mass, the value is not going to change. So, m by m. Now, what's the purpose of doing like this? Now, look at the numerator. We get half is there. M into m is m square v square divided by m. Okay, m square v square, that is mv the whole square, right? What is mv? mv is linear momentum. Linear momentum is p. So, we can write it as half p square by m, or rearranging, we can write it k is equal to p square by 2m. This is the relation between what? Kinetic energy and momentum. It's a very simple equation, right? I think all of you know it. Kinetic energy is equal to p square by 2m. p square by 2m. So, it's a direct relation between kinetic energy and momentum of a body. Now, why is it important means always there will be some tricky question based on it. So, let's discuss one of such question from this. It's a repeating question for the competitive exams and all. Just like, this is the question. Listen carefully. If the momentum of a body is increased by 20%, momentum of a body is increased by 20%, what is the percentage increase in its kinetic energy? Momentum is increased by 20%. What is the percentage increase in its kinetic energy? Percentage change in kinetic energy. So normally, if a question comes to find the percentage change, for example, x is a quantity, any quantity x, and you have to find the percentage change in x. If x is a quantity, what is the basic way to find percentage change in a quantity? It is change in x. That means if you are representing change in x as delta x. Change in x divided by its original value, initial value of x. So change in x by original value into 100%. This is a standard method of finding the percentage change in a physical quantity, delta x by x into 100%. Okay, so in this question they are asking momentum of a body is increased by 20%. So momentum is changed by 20%. Then what is the percentage increase in its kinetic energy? You can use this same formula, but here I'd like to explain in a shortcut way. So there is a shortcut, very simple way. Within 10 seconds, you can find the answer for this type of question. So I'll be explaining such a shortcut in this class. Okay. So listen all of you, please. We don't need to take this formula, a simple technique to find the answer for this question. Okay. So for that, we'll take this equation. What is the equation? Relation between kinetic energy and momentum is, you know that k is equal to what? P square by 2m. P square by 2m. Here, if you're reading the question, you can see that if the momentum of a body is increased by 20%, momentum of a body, so body is fixed. We are not making any change on the body. Momentum of a body is increased by 20%. So since the body is fixed, there is no change in its mass. Mass remains constant. So mass remain constant means the change in momentum is only due to the change in velocity. Because you know that momentum is mass into velocity. So please note that mass is a constant. Mass of a body is constant. Since mass is constant or conserved, can we write Ke is directly proportional to p square? Because other terms are constant. 2 is a constant, m is a constant. So K is directly proportional to p square. That means as p square increases, kinetic energy also increases. This formula will help you to find the answer for this question very easily. How? Listen. Here in this question, what they are giving is the momentum of a body is increased by 20%. So let's take a simple example. What is the initial momentum? They did not say what is the value of initial momentum. Only data given us increased by 20%. We have no idea about what is the initial value, what is the final value, but there is an increase of 20%. So for our simple calculation, let us take initial momentum. I am representing it by the letter P1, P initial, P1. Let us take it as 1. It's a shortcut, you can easily find the answer from it. So initial momentum is what? 1. If initial momentum is 1, what will be the initial kinetic energy? A proportionality relation is enough. K proportional to P square, then KE1 will be proportional to 1 square. 1 square is what? 1 only. So if initial momentum is 1, final momentum will be proportional to what? 1. Very simple. Now, very careful. Momentum is increased by how many percentage? 20%. 20% increase in the momentum. Please note that. What is the initial momentum? 1. That 1 is increased by 20%. What is 20% of 1? 20% of 1 is how much? 0.2, right? 50% of 1 is 0.5. So 20% of 1 is 0.2. Initial momentum is 1. That momentum is increased by 20%. So 1 plus 20%. 1 plus 0.2. What will be the new momentum? New momentum is P2 is equal to what? 1 plus 0.2. 1.2. Yes or no? 1.2. So here, students, please note that in the question, if they are asking if the momentum is increased by 30%, then what will be P2? 1.3. 40% means 1.4. Like that, you can easily write it. 50% means will be 1.5. Okay, then what will be the new kinetic energy? Ke2 will be proportional to 1.2 square, right? 1.2 square, square of 1.2. 12 square is 144. So 1.2 square will be what? 1.44. That's it. Is it clear? Now, what you can see, initial kinetic energy is 1, final kinetic energy is 1.44. What is the increase there? 1 becomes 1.44. So the change, you can see that it's 0.44. 0.44 change is there in the kinetic energy. 0.44 change means if you're converting into percentage, into 100%, what will be the answer? 44%. So the increase in kinetic energy will be how much? 44%. I told you can find the answer for this question in 10 seconds. See, in the exam they are asking if the momentum of a body is increased by 30%. 30, just quickly you can reach. 30 means 1.3. 1.3 square, 169, so 69%. Even 10 seconds is not required, right? So this is just a shortcut to find the answer for this kind of question. So please be careful while doing this. Don't make any silly mistake. I hope this idea is very clear. You can easily find the percentage change in kinetic energy using this method. Yes, thank you very much, students.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.